Number 7, determine whether the function f of x is continuous. If it is discontinuous, classify each discontinuity as infinite, jump, or removable. Well, I can tell you right off the bat, just looking at this, we know it's not continuous. How do I know that? It's because you're never allowed to, in mathematics, divide by 0. And if you have x in the denominator, there's a potential case you're dividing by 0. So continuous is out. Not only that, jump requires either to have a piecewise equation, where you have multiple equations working together, or to have the greatest integer function, which is that function that has these brackets. It looks like a step function. It looks like stair steps, which we do not have. So jumps out of the equation as well. It's either infinite or removable at a maximum of 2 locations, since my power is 2 in the denominator. So here's what we do. We need to factor these to find out what's infinite, what's removable. So I want to factor both the numerator and the denominator. I'm going to do the numerator first. So we could come over here and say, what are factors of a times c that add up to b? In this case, my a is 1, so 1 times -6 is -6. My b is -1. What are factors of -6 that add up to -1? That would be -3 and +2. That multiplies to be -6. But yet, when they add them together, you get -1. Since you now come back over here, you split this power, so it would actually become x minus 3 times x plus 2. As for the denominator, just kind of draw a line here. Notice that there's a GCF. So the first factoring I would do is factor out the GCF, which would leave me with x squared plus x minus 6. So I factored out that 3 out of all the way across. And now I do the same type of factoring. X method, here's my A, here's my B, here's my C. So factors of -6 add up to +1. This time, since it's still factors of -6, but they add up to +1, I would switch these values. So I would need to have values of 3 and -2. Again, I would take my power here, and I would split it, and so it would be 3 times x plus 3 and x minus 2. Now that I've factored both the numerator and the denominator, I would put them back over each other. Say f of x equals x minus 3 times x plus 2. I realize I left out the parenthesis there. Over 3 times x plus 3 x minus 2. Now, can I cancel any factors out? Are these two identical? They're not. I know they look like it, and so do these, but they cannot cancel each other out. Since nothing cancels, they're not removable. Removable mean they would cancel out or simplify and be gone. So our two discontinuities would occur where the denominator equals 0. It would be when we have a 0 down here. The only way to multiply and get a product of 0 is that you have to multiply by 0. 3 cannot equal 0. It's just impossible for 3 to equal 0. So I don't have to worry about that. That's not as, but here, if you set this parenthesis equal to 0, x would equal -3, we would have problems. And here, if that were equal to 0, you'd have that x would equal 2 being problems. So at x equals -3 and +2, we have discontinuities. These are both infinite discontinuities because they did not get canceled. So this here would be our answer for number 7. Now you could graph this and you check, and remember, infinite just looks like a vertical asymptote. You'd have 2 vertical asymptotes.